All right, we're going to do a couple factoring problems just to get you ready for the test. Okay, so you have this factoring quiz. It's a practice quiz. Let's look at number 2 first. We're going to do number 2. We're going to do 2 through 6. All right, let me outline this first. Sorry. Okay, so the first thing you always want to check for when you factor is for a greatest common factor. In number 2, is there a greatest common factor? There is. Let's start with that. We're going to factor out a 2, which is the greatest common factor, and we'll have 4x squared minus 25. The next thing you want to check for inside of here is if it's some kind of special case. Is it a difference of squares, or is it a perfect square trinomial? If it's neither of those, then you move on down your list. You look for maybe factoring by grouping or trial and error. This is a difference of squares, and it will factor more. This will factor into 2x plus 5 times 2x minus 5. Don't forget to always tag on the greatest common factor if you did factor something out. All right, let's look at number 3. First thing you ask yourself, is there a greatest common factor? There's not. Is it a special case? Is it a difference of squares? Difference of squares only has 2 terms, so it's not that. Is it a perfect square trinomial? Well, the perfect square trinomial has to have perfect squares in the first and last term, and 15 and 3 are not perfect squares. Then you'd see if this was going to be factored by grouping, but there's only 3 terms, so this is just trial and error. All right, now you have to ask yourself, first times first has to be 3x squared. So you only have one option there, 3x and 1x. Then your last slot needs to be 2 numbers that multiply to give you positive 15. But notice your middle term here is negative, which means both of these are going to be negative. The only way for you to have a negative middle term and a positive last term is if both signs on the binomials are negative. All right, so our options are negative 15 times negative 1 or negative 3 times negative 5. So let's try the 3 and the 5. Now if you put the 3 in this spot, you can see that in this factor right here, there's a greatest common factor of 3. If that happens when you're factoring, that is not going to be the right way to order it. You're going to eventually have to change the order. So anytime you're trial and error and you put one guess in and you realize that there's a GCF in one of the factors, that's not the right order. So I'm going to put negative 5 there and minus 3 there. Then I'm going to FOIL and check. So this is 3x squared, outer is minus 9x, inner minus 5x, and then plus 15. And yes, the middle term does add to negative 14. Okay, so good. Let's look at number 4. Okay, first ask yourself, is there a GCF? No. Is this a special case? Is this a difference of squares? No, difference of squares is only 2 terms with a minus sign. Is this a perfect square trinomial? A perfect square trinomial has the first term and the last term being perfect squares, and the middle term has to be twice the square root of the first term, which is 3g, times the square root of the last term, which is 4. And that is true. The first and last term are perfect squares, and the middle term is twice the square root of the first term times the square root of the last. This is a perfect square trinomial. So this will factor into some binomial squared. Your first slot that goes here is the square root of the first term, so 3g. In the last slot goes the square root of the third term, which would be 4. Now for the sign, if all 3 signs or 2 signs are positive, then you have positive here. If you had a negative right here, let's say you had that negative, then the sign would have been negative. All right, let's go on to the next one. All right, number 5. Let's go down our list. Is there a GCF? No. Is this a special case? Is it a difference of squares or a perfect square trinomial? No. Can we factor this by grouping? Are there 4 terms? No. This is just trial and error. All right, now one thing also, this is an easier trial and error because the first term on x squared is 1. Okay, so we automatically know what goes in first times first. That would be x and x. And then for the last 2 slots right here, we need to find factors of negative 33. Factors of negative 33, I can only think of 2 pairs. Well, I guess there's 4. 1 and 33. You could do negative 33 and 1, negative 1, 33, and then 3 and 11. Okay? So you want to find factors of negative 33, one of these 4, that adds to be positive 8, because your middle term is this positive 8. So anytime your coefficient on a trinomial here is 1, all you have to do is list the factors out of the last term, figure out which one of them adds to the middle term. All right, and that's going to give me this guy right here, negative 3 and positive 11. Okay, I'm going to clean this up a little bit. And I'll write that in the same color. Okay, let's just check to make sure. First times first, x squared, outer, plus 11x, inner, minus 3x, and then last, negative 33. And yes, the middle term does give you positive 8. All right, last one. First, check for a GCF. Is there a greatest common factor in number 6? No. Check and see if it's a special case. Is it a difference of squares? No, there only has to be 2 terms for that. Is it a perfect square trinomial? No, a trinomial has 3 terms. So the next thing I would check for is if I could factor it by grouping, meaning are there 4 terms? And there are 4 terms, so that's what I'm going to do. I'm going to group. So for grouping, you split this up into your 2 pairs, and then in the first pair you ask yourself, what's the GCF? It looks like that is 7m squared, and then you factor that out of the first 2 terms. So when you factor a 7m squared out of 28m cubed, you'd be left with 4m. And when you factor a 7m squared out of a 7m squared, you're dividing 7m squared by 7m squared, which will give you a positive 1. Okay, let's look at the second pair. We want to factor something out of the second pair so that we also end up with a 4m plus 1. If we want to end up with a 4m plus 1, we need to factor out a negative 2. When we do that, we're left with 4m plus 1. Okay, here's where everybody gets confused. Basically, what you're going to do is you're going to look and see what was common in these 2 terms. You've got the 4m plus 1 is common. You're going to factor that out, 4m plus 1, and you're going to be left with whatever you've had factored out earlier, 7m squared minus 2. And that's it. All right, so just don't forget to always take out the GCF first and then continue to factor for all of these types. And then don't forget to include the GCF in the end.